We are gonna start a little bit later as usual, but it's good because there's still some people arriving. So thanks for coming. We will start with the first talk that is about Guillermo, that will talk about Fountain and Python functional programming, and after that will be Jordi. So let's clap your hand for the first speaker. Go ahead.
Hello everyone. So it's acceptable? Yes. Let's try. So we are going to talk about functional programming applied to Python. First, we are going to answer the question if Python is actually a functional programming language. Then move to some history about functional programming, and try to understand what means functional programming, and end up applying functional programming to Python. This is just because you can try to believe me. I'm not a high school student. But let's go to the interesting part. Is Python a functional programming language or not? Raise your hand. Who thinks that Python is a functional programming language? 1, 2, 3, 4, 5 thinks that yes. And who thinks that it's not a functional programming language? Okay. So you can more or less translate this question to this. Is Spain a kingdom? Who thinks that Spain is a kingdom? Who thinks that Spain is not a kingdom? So the point is that it depends. What do you mean by functional programming? For example, in the case of kingdom checklist, you need a king as a first-class citizen. At the same point, functional programming, you need functions as a first-class citizen. And Python have functions as first-class citizen. But for a kingdom, you need that the king rules the world. In case of Spain, it's not. In functional programming, you need that functions rules the world. And in Python, it's not. The same for the tool set, the amount of features that surrounds this entity. Interesting. What we have instead of this? In the case of kingdom, the world is ruled by the parliament. And in Python, the world is ruled by classes and objects. And the same for the features. We have a large amount of features for classes, but not for functions. Yeah. So we can end up with that Python is not a pure functional programming language. And this word "pure" is important because it's defining what we are talking about. And let's read it. I have never considered Python to be heavily influenced by functional languages, no matter what people say or think. I didn't view Python as a functional programming language. However, early on, it was clear that users wanted to do much more with lists and functions. That's the words of Guido van Rossum, that is the founder of Python. Let's talk about, try to understand what's functional programming by its history. Yeah? In early 20th century, there was a great crisis in mathematics about its foundations, thanks to number theory and set theory. Mathematicians started to think about this crisis, and they developed a lot of tools to try to solve this crisis. And one guy, alone for charge, developed lambda calculus trying to solve these paradoxes that rise in the crisis. And lambda calculus is what we use to define functional programming. So we can say that functional programming languages, the theory behind these languages is lambda calculus. So it's based on mathematics. On the other hand, procedural programming languages, like Python, can be explained with extensions of lambda calculus that are no longer lambda calculus. So we can summarize this fact with this, a family tree of programming paradigms. On one hand you have mathematics and two children, logic programming and functional programming, and on the other hand, early on electronics that develop assembly languages, then structured programming, object-oriented. So you have here Python and functional programming on the other side. So we can, at the end it's simpler to think in two sets, the declarative languages and imperative languages. They were born with different fathers, so they are completely different. Most languages we use are imperative, like C, Python, Java, Net. But we know some of the declarative languages. For example, SQL, regular expressions, and XML are declarative languages. And all of them are based on some sort of mathematical theory. So it's not strange, a declarative language, we know about them. And functional programming is a declarative language also. So let's try to define the rule of functional programming. It doesn't matter if you don't understand this slide right now, just try to find that it is a rule that functional programming languages have to fit. There are one thing that is called call by value. What means calls by value means that when you're going to call a function, you first evaluate the argument expressions and then put the evaluation inside the function arguments, and then execute the function with this replacement. This is the way we usually think about functions. But we have also a call by name. That is, instead of first evaluate expressions and then call the function passing the values, we just pass the expressions to the function and let the function evaluate the expression of its arguments on the runtime of the function. If these two things results in the same value of the function, then we're talking about functional programming. If a program fits this rule, you can talk that the program is a functional programming style. If a language forces you to apply always this rule, then the language is a functional programming language. Actually, you can break it, but when you're going to break it, you have to tell to the language that, hey, compiler, I'm going to break this rule. So this rule ends up in some more daily facts and recognizable facts, like functions in functional programming have to be understood as mathematical functions, not as routines. So a function in mathematics does not change the world. A function in mathematics, you put some value and the function returns another one, but the world is still the same. That's the point too, that there are no implicit side effects. The point one, says that one function with one argument returns always the same value, independently of the time. So it's deterministic. Also in functional programming languages, you have, instead of loops, recursion. And one classic example is, or you can define a list. A list, this is the way to define a list with a recursion, that list is nothing if it's empty, or is a value and a list. Sometimes a list can be nothing, or a list, a value and a list. Then you can use this reference that is recursive to expand your list as many values as you want. Also, you need higher order functions that are functions that take as arguments another functions and they return functions. And pattern matching, covering, and monads, well, since you don't have them in Python, you can try to simulate them, but it's not going to talk about this right now. What we have in Python? In Python we have that functions are first-class citizens. And I'm going to show something about this right now. We have higher order functions, so since Python is a dynamical language, you can pass the function wherever you want. As a function, there's no problem with that. You have function closures. That means that a value is local within the function when you define it. And lambdas, inline functions, and some basic tools about functions that actually doesn't matter a lot. But let's say what I mean with functions are first-class citizens asterisk. I need a console and the guy at the computer is gone.
The black screen.
This one?
Yeah.
Okay. Great. Let's start with what we know. Sorry, keywords. And 4 spaces, sorry. I am trying to use a tab. Okay, we define a function and then we ask to Python what's the type of f.
Please, you can go to the
Yeah.
increase the size.
Oh, you can increase the size.
I don't know.
You don't know also, okay. Huh?
How many? Who wants 20? 20 more?
24.
24?
Yeah.
Too much, no?
It's okay.
It's okay?
So the type of
Maybe the people of the end, you can see? Okay.
okay.
So
You
the
cannot see
type,
what he's typing, but
we don't see the last line.
That's fine.
The line you are typing, we don't see it.
Es como que está cortado abajo, por lo cual apretamos
Okay,
3 veces
don't worry.
enter para que...
Okay, thanks. So we define a function and we ask to Python which is the type of that function, and Python answers with class name function. Okay. So functions have its own class. I have this. Yeah. So we just inspect module to ask about the code, the hierarchy of classes, and we ask the Python tell us all the classes that implements this object F, the type of object F. And Python says that F is an object and then a function. So functions have its own classes, its own class, but it's still an object. Let's try with lambdas. Yep. And the same. And Python says the same, that a lambda function is a function, nothing more. Which more ways we know to define functions? For example, with classes. A class with one method. So okay, it's still a function. What will happen if so well, we define an instance of class Klaus, K, and we ask which is the type of the method K of this object, is no longer a function, it's a method. So it's not the same type. So Python have at least two ways to define functions. A class function and the class method. Why? That's because a function is not bound, and a method is a function that is bound to an object. But we know it's still one more way to define a function. It is with this. Let me show you. You know call? Yeah? So we have an instance and we can call this instance as a function. It's an object. Yeah? We have done this and then it's so we define a class that implements call, then we have an instance of this class, and we can use this instance as a function. Yeah? So this object acts or behaves like a function. Let's ask to Python if this object is related with function class, but it's not. There is no function class. It's just the instance of one class and instance of object. And just because we are curious, call is still a method. So at the end, okay, one step further, do you remember the function f at the beginning? Let's ask to function f if we have call. Yes, the function f, that is simply a function def f, has a method proper with the name call. So what means method proper? The point is that Python at the end summarizes all the ways to call functions with this method call. Sometimes this method is logically exists, or sometimes this method is virtual and actually doesn't exist and is a method wrapper. So if you want to ask to an object if you can call the object as a function, just ask you have to ask to the object this. If this statement returns true, generally you can use f as a function. independently if it's a lambda or a regular function, or if it's a class that implements code. Okay, so summarizing, functions, we have 3 types of functions in Python, but you can almost forget about the fact that there are 3 different ways to define functions, because you use them in the same way also, and Python manages this difference. But you have the class function that implies that Python uses functions as first-class citizens. Okay. So next, let's try to make some experiments. Yeah. I'm going to define one Python program and transform this simple program to a functional program. Yeah. So we define a function, list square, that takes a list, and for each element, for each index in the list, takes the element in this position, squares it, and assign this result to the same place of the object, of the array. Therefore, if we define this list and we execute this function, the value of this variable is going to change. Yeah? So this function changes the state of the world, the past. K is not going to be longer the same. If we want to transform this to something more functional, we cannot let the function list square to change key. So how can do it? Just put the result in a new array. Okay, so we define a new list with the same size, and we assign to the new list the squared values of the list we took. At this point, the list K is the same. We have a new object with the new values, but the past state is still the same. Still we have problems, because within the function we are changing the state. We have one variable, and this variable is changing the state of themselves, changing the values within. And functional programming says that you cannot do this. You cannot change the values of this array once you define that this object exists. Objects have to stay immutable. That's one way to do it. Actually, 2 ways. The first function uses 2 lambdas. This lambda is just, you can replace this lambda with def, a regular def. But the point here is that we are going to take a list, and we are going to apply to each element of the list x squared. Map means that apply this function to each element of this list, and return a new list with this function applied. List square 2 is a function that takes a list and map the values of the list to its squared values in a new list. So if we do this, we execute this function over K, we have a new array with the values we want. K is the same, and here we don't have a state in this function. Therefore, this is acceptable from the point of view of functional programming. And if you want in this expression that is nicer, is the same. And even better with generators. And one interesting point of lambda calculus and functional programming is that since the state of the world doesn't change, you are only declaring how the world is. You can let the computation execute later. That means that here we are defining a function that takes a list and does the same as before, it squares every element of the list. But this parenthesis means that we are not going to compute the value now. We're going to let the computation for later, when we need actually to compute these values. So at this point, we have the list K that is the same, and this list that actually is a generator, that we don't have the values here still. But when we are going to ask for this variable, which values do you have, he's going to answer with the square values of K. Yeah? So we have less evaluation of the new object. And that's a hard example to explain higher order functions, and ends with one nice function. So the statement is, given functions, for functions, an array of data, D1, D2, wherever, compute this function. So apply to each element of D the composition of all 4 functions. If you want to do it straightforward, you have something like this. Yeah? Hard-coded, completely hard-coded. You define a function that takes the data, takes 4 functions, and you are going to override the values of D with the computation of these 4 functions nested. That's ugly, and also you are overriding the values of D, and you are computing all at the same moment. Also, you are forced to use 4 functions. If you have 5 functions, you have to change the method. If we apply the same law that we have to preserve the state of the world, we end up with this function that is the same as before. We define a new function, and we assign the values of the computation to that new function and return this. I missed the return feature. But you get the idea. We're going to change the statement. What happens if we have a list of functions and not simply 4 functions? The straightforward way is two loops. Okay. I have a list of data and a list of functions. I'm going to iterate over the list of data, then over the list of functions, and apply and override the values of D to this, the result of the function number J of data number E. Okay, that works. Actually works. If we want to do it the same, preserving the state, we just copy the array and execute the same. No problem. But we can do it even better, because let's show it's quite strange. Don't worry, I'm going to explain this. Higher order functions are functions that take functions. Actually, this is a higher order functions, but here we take a set of functions, a list of functions. But let's understand this line. 3 lambdas and 1 reduce. Let's start from the inner side, this lambda. Lambda takes a value x and applies 2 functions, first one and then the other, over x. Okay. Then let's study this lambda. This lambda takes 2 functions and returns a function, lambda function, that is the previous. So we put this f1 to f1, f2 to f2, and x to x. The value, the return of this lambda is an actual value of data, but the return of this lambda is a function. This function. What means reduce? Reduce is when you have a list and you want to summarize the list to one single value. For example, you have a list of numbers and you want to sum them all together. to reduce a function, you have to define, to reduce a list, you have to define one function that takes two elements of the list and sum up together in just one. That is what we are doing here. Reduce the set of functions, the list of functions f, with this operation. So we take first the first two functions of this list, and we apply to this function. And this results in just one function. Then take this result and take the next element of the list f. And repeat, apply this function. And returns one function. So if you unwrap this reduce, it's just doing if 1 of x, then if 2 of the result, then if 3 of the result, then if 4, and so on. So this reduce is the composition. We are executing the composition of the list of functions. This function stack functions takes the list of functions and returns one single function. That is the composition of all the functions in the list. And let's apply it. We stack the functions f, that is the list of functions, and this returns a function that is the composition of f, of the list of functions f. And then apply this composition to d. That d is each element of the data set. Yeah? So that's a function that takes a list of functions and returns itself as a function, and we apply this function to each value of d. And furthermore, that's a generator, so we don't evaluate this data until we need it. Yeah? That's one problem most of the functional programming style things you can do with Python. You are preserving the past state. The state of your function, actually your function has no state, and there are no values changed in your function because you are computing them on the fly. So that's, from the point of view of functional programming paradigm, that's okay. Still, you cannot do much more with Python. So, just to summarize, if you want to learn functional programming, don't take Python. Use Haskell or Scala. If you want to, but okay, let's say that you don't want to learn functional programming, but you think that this is interesting. The point is that you have to be productive. You have to develop things quite fast. And functional programming sometimes can help you to be more productive. So it's about wisdom. Choose when to apply functional programming in Python. Not always, because it's impossible, and don't write programs in Haskell, please. So use Python with object-oriented programming, that is the industry standard, and choose when to use Python functional programming style to be faster, or to be more expressive, or develop better programs. That's the conclusion of functional programming for Python, with no doubt. Yeah, absolutely. Questions? Please. Thanks.
When you say about speak about functions of first-class citizens, are functions in Java first-class citizens? They are not, right? Because you can pass them around stuff.
In Java 8, they are. In Java 7, they are not.
Because you have lambdas.
In Java 8 you have lambdas, and also you have method references.
Okay.
Like in C++.
And without C, where you have pointers to functions. Does
You
this count?
The point is that if you define a language around functions functions with no doubt are first-class citizens, and actually the unique citizen. The point is that how can you emulate this in other languages? In Java 7, you can emulate functions with interfaces. There's no problem about this. You can do it. So most of the time, you can put a lot of functional programming style in many object-oriented languages, but you are not actually empowered as in Scala or in Haskell. So you can emulate this functional programming style, but you're limited. That's the reality. Yeah? Other questions?
Why are you advising against Blasco?
I am sorry.
No, you have to just why are you?
I mean,
Your reasons for not using Haskell?
I respect Haskell. I mean, come on. That's sort of the joke in engineering and object-oriented programming. I have nothing against Haskell for sure. Actually, I like the Haskell background based in mathematics, and you can prove a lot of things with Haskell, but you cannot do it in regular languages and procedural languages. I have nothing against Haskell, obviously.
Because I moved something from Python and Haskell, and I'm very happy with it.
Next. Hello.
Yeah, I just wanted to know which is the overhead when you use the lambda functions, when you, with this approach of the reusing all the lambdas.
You have
yeah, compared to a normal function. I mean.
Yes, the point is, it depends in the runtime you use for Python, because you have CPython, PyPy, and they are some more oriented to be dynamical, and other more oriented to be static. So for example, in CPython, the Python is compiled to C, and lambdas are simply an evaluation of the result of this string. So you have an overhead if you use a classical all compiler, but if you use a compiler of nowadays like PyPy, the overhead is not that hard. For sure, a regular function is going to be faster because Python is built on top of this. Hello.
Do you have any if you try to develop this way in Python, me as a classical developer, I tend to use objects and classes, and I've been reading a little bit about this kind of programming. And how do you organize the functional style Python? I mean, you put the functions right away in modules, or you do it inside objects, trying to not share the state, or do you have any heuristics on how to do this?
Yeah, sure. Actually, the structure of the program is also in modules because you have to follow the modularity and isolation of logic. You are going to end up with library of functions. I mean, the structure is going to be more or less the same. What it changes is the way you think which objects are going to change its state. That in case of functional programming is the most known. You are going to create new state in any case. So, it will be easier to show you that I have no a complete functional programming program. That the structure of the code is closely related because what we learned about modularization, structure, dependencies, isolation, you want to apply them also. And the point that functional programming implies no side effects in general also enforces you more to do this.
But what you are doing then is you keep the state instead of having your class instances, you have dictionaries, and then you pass around the dictionaries to the function so that and you maintain the state.
You can have classes perfectly. You can have a class that has some attributes. The point is that once the classes have an instance, this instance you don't want to change it. There are a few strategies to deal with mutability. If you want to change the state of this wall, how you're going to do it? The simplest way is to update the state. You have you pass the state as an argument and you return the new state. Okay? Another way is to use monads, but monads are quite complicated to explain, so I skip this part. But you have a specialized mechanism in functional programming to deal with mutability. Actually, the point is that you have to deal with it. If you are going to query a database, the database state is going to change no matter what. So you have to deal in the real world with mutability of the state. So there are techniques, and I suggest you to try, for example, in Scala, that is going to be easy for you. And for example, in Scala, you can define a variable that is going to change and a variable that is not going to change. A var and a val, a value and a variable. So this enforces you this value to not change it. I suggest you to try. Yeah, so just let me say one thing. Please, I suggest you to check out this project. It's super interesting. Yeah, Lichen. It's about researching new ways to explore the ways to explore and search in internet. And also, my company, we are looking for Java developers. So if there are some Java developer that needs a job, send me a mail.
Thank you.